All right, section 4.2. We have more exponent rules. So we're going to talk about negative exponents, which I mentioned in the last lecture, but this time we're actually going to learn what they are and how to use them. We're going to talk about zero as an exponent, quotient rules, and then put them together. All right, so before we get started, I want to do a little, I want to show you something. I want you to see a pattern. So let's suppose I have 3 to the 4th, 3 to the 3rd, 3 to the 2nd, 3 to the 1st. Okay. And we know 3 to the 4th. And if we multiply that out, we get 81. And 3 to the 3rd, we multiply that out, we get 27. 3 squared, and we get 9. And 3, which is just 3. Okay. So as you can see, I have, as I start here and I go up, I'm multiplying by another 3 each time, right? So if I had 3 to the 5th over here, I would be 3 times 3 times 3 times 3 times another 3, and that would equal whatever. But let's suppose I already knew 81. I already knew this, right? I already knew that this was 81. If I wanted to find 3 to the 5th, instead of starting back from the beginning and multiplying 3 times 3 times 3 times 3 all over again, I would just take 81 and multiply it by 3. I think it was 243 if I recall correctly. So my point is, as I go this way, I am just multiplying each successive term by 3 to get to the next one. So 3 multiplied by 3 gives me 9. 9 multiplied by 3 gives me 27. 27 times 3 gives me 81. 81 times 3 gives me 243. All right. Now what I'm going to do is I want you to notice this pattern right here. So I've got a 5, a 4, a 3, a 2, a 1. If I wanted to go this direction, what would be the next exponent that we would use? Well, 5, 4, 3, 2, 1, the next number is 0. And yes, indeed, the next number in the pattern is 3 to the 0. So instead of going up, this time I'm going down, okay? So to go up, I multiplied by 3. If I want to go down, I'm not going to multiply by 3. I'm going to divide by 3. If I have 81 and I want to get to 27, I have to divide by 3. If I have 27, I want to get to 9, I divide by 3. I take 27 divided by 3, I get 9. 9 divided by 3 gives me 3. Well, how would I get to the next one? Well, just divide by 3. If I take 3 and divide it by 3, I get 1. And this is important right here. Anything to the 0 power is equal to 1 because of this pattern. So if I had, let's do 4. 4 to the 3rd, 4 to the 2nd, 4 to the 1st, 4 to the 0. 4 to the 3rd is 64. Divide by 4, I get 16. Divide by 4, I get 4. Divide by 4, guess what? I get 1. Anything to the 0 power is equal to 1. Okay, that's important. If I were to extend the pattern, 5, 4, 3, 2, 1, 0, negative 1. Again, I divide by 3. Well, 1 divided by 3 is 1 over 3, 1/3. What if I had 3 to the negative 2? Yeah, divide by 3. So if I have 1/3 and I divide it by 3, that's equivalent, remember, keep, change, flip, 1/3 times the reciprocal is 1 over 3 times 3, or 1 over 3 squared. which is 1/9. Again, if I have a negative exponent and I want to write it as a positive exponent, this went from the numerator to the denominator. My exponent, excuse me, my exponent stays a 2, but now from -2 becomes a +2. Okay, not the number itself, not the 3, but the 2. Okay, so there we go. Why do these two powers, or why do these two rules work? Because it fits the pattern, right? It fits the pattern. So let's do it a little bit more officially. Okay. Anything to the 0 power is equal to 1. 17 to the 0 power is equal to 1. 7 to the 0 power is equal to 1. -7, the quantity of -7 raised to the 0 power is equal to 1. This is not the same thing as b. This is saying take 7 to the 0 power and then make it negative. This one's -1. 1, 1. Final answer is 2. Anything to the 0 power is equal to 1. Got to be careful with that negative in front, though. And this is exactly what I showed you on that first slide. If I take anything and raise it to a negative power and I write it as a positive exponent, 1, I have to do the reciprocal. Okay? By the way, it doesn't literally mean put it in the denominator. What it actually means is reciprocal. So if I have, for example, W1 over W to the -3, and I wanted to write it with a positive exponent, I wouldn't put it in the denominator of the denominator, I would put it in the numerator. So anytime you have a negative exponent, it moves either bottom to top or top to bottom, but it has to move. And moving it from numerator to denominator, denominator to numerator, will change the exponent positive. All right, 4 to the -2, 1 over 4 squared. If we simplify that, we get 1 over 16. This one can be done a couple different ways, and I'm going to show you both ways, actually. So I'm going to show you one way with this fraction and a different way with this fraction. So we're going to apply the exponent to each one inside. 1 to the -3, 4 to the -3. Okay, so this has to move to the denominator. This has to move to the numerator. Okay. And 4 to the 3rd power is 64. 1 to the 3rd power is 1. Final answer would be 64. Okay, this is one way of doing this problem. There's actually a different method that you may choose. It's up to you. Notice how I started with 1 over 4, but I ended with 4 over 1. Okay, so what you can do is you can actually take the reciprocal of this fraction, 5 over 3, and then make the exponent positive. So we kind of skipped this step right here. It's up to you. So we have 5 squared, 3 squared, 25 over 9. Be careful with this one. We're adding. So 1 over 2 to the first, 1 over 5 to the first. Common denominator would be 10. Oops. So we have 5 tenths plus 2 tenths. Okay. 1 over m to the 3rd. Now, students see this and think they have to do something with it. You don't. This is just telling you that you will not end up with 0 in the denominator, which you know is not allowed. We can't have 0 in the denominator. So this is just saying you don't have to worry about that. You don't have to actually do anything with it. All right. This is saying what I got done saying on the last slide. So this right here, we can basically, you can flip it first, you know, right here, or you can apply the exponent first. Doesn't matter. All right. So first thing I want you to do, if you have an exponent on the outside, then you are going to do that first. If you don't have an exponent on the outside, then do negative exponents first. Okay, so kind of an order of how you should probably do so. It's not required to do it in that order. It's just usually a little bit easier to do it in that order. So exponent on the outside, and then negative exponents. All right, so we've got 3 to the negative 3. That does have to move to the numerator, and 5 to the negative 2 has to go to the denominator. Notice my exponents become positive 27 over 25. Okay, so we have negative exponents. So this, oh, be careful. This is 4 to the first power. Okay, it is not, it does not, these are not glued together. The 4 doesn't go with the h. The 4 stays on top, has a positive exponent. But the h does have a negative exponent, so we're going to put it on the bottom. M has a negative exponent, we're going to put it on the top. And k has a positive exponent. It's going to stay put. We don't have to simplify the coefficient, and we don't have any variables that we have to put together. All right, so negative exponent on the outside, I am going to flip this fraction, take the reciprocal, but be careful. We're only doing this negative exponent, not this one, at least not yet. So when we flip it, 2y cubed, this is still x to the negative 2 to the positive 3. Okay. When we flipped this fraction, we're only dealing with this negative exponent, not this one. So now we're going to apply, actually, we still have a negative exponent. So I'm going to take this, I'm going to put it in the numerator. 2y cubed x squared. We actually don't have anything in the denominator at this point. And I'm going to apply the exponent to each of the ones inside. And x squared. 2 to the third power is 8. Multiply the exponents. And that would be our final answer. We've simplified the coefficient. Our answer does not have any negative exponents. And we've only written the variable ones. This one, remember that 4 has a positive exponent. Okay. I think this is where I wanted to stop. So I am going to stop here for this video and then pick it up in the next video.